Hi, and welcome back to this tutorial on inheritance. In our last example, we defined three classes, machine 1, 2, 3, and we instantiated the classes. We printed out the method in machine 3, which showed I can write, and we tried to also call the walk method, which belongs to machine 1, using the machine 3 instance, and it gave error because that method doesn't belong to machine 3. To make it belong to machine 3, we inherited all its method by adding it to machine 3. Machine 3 inherited machine 1, and so by that, the walk method in machine 1 became available in machine 3 instance. We also tried to run the run method in machine 2 under the machine 3 instance, and that didn't work because machine 3 doesn't have run. So what we did was inherit the machine 2 class into machine 3. This we called multiple inheritance. So machine 3 instance can now run all the methods in machine 1 and also machine 2. If you look at this code, machine 3 is able to do the run method in machine 2 because it inherits the machine 2 here. Let me add a little bit more text here. So in machine 2 is showing I can run as machine 2. So you see machine 3 is calling the run method in machine 2, and that's why it's still showing machine 2. Machine 3 right now is running like machine 2. It's not running like machine 3. So in this instance, we can do a method override. That is, create a run method on the machine 3, but specific to machine 3. So I'm just going to copy the run method here and then call it I can run as machine 3. And you can see right here now, when it calls the run method, it's calling its own run method. Is no longer calling this one. If it doesn't have its own, let me comment out this. It's going to be calling the run method in machine 2 because it inherited machine 2. So, but if you have its own, it's going to be calling the run method in machine 3. So it's overriding the parent run method and it's using its own specific run method. This brings us to the word super. Super in Python inheritance means run the parent method. So in this instance, I can do super. This is how we call it. Super whatever parent method you want to run. So I can say super run. So what that does is that it first run this. That is, it does the parent method, and then it can now do its own method. So right now, machine 3 is running as machine 2 and also as machine 3 because in the code for machine 3 says, first of all, run the machine 2 method, and then you can now do your own method. The super keyword connects you to the parent class and the methods in the parent class. Technically, what we are doing is morphing or transforming machine 3 class to behave like machine 2. Look at it again. When you do the run method, let me comment this out. Machine 3 runs like machine 2. It is calling the machine 2 run method. But when you put this back, it calls the run method for machine 2 and then it calls the run method for machine 3. So that means when you call on the instance the run method, it can morph itself into either working on the machine 3 run method or working on the machine 2 run method. This inheritance and overriding of method is called polymorphism in object-oriented programming. Let's take another example of a person class. So I'm going to write class person and I'm going to instantiate the class and taking age and name, and then I'm going to have a method called party and print out is party time. Let's instantiate person, and you note that during the instantiation we have to put in the name and the age as shown here. Before we call the party, let's add some more text here. So I'm going to say it's party time, check in, cell.name to see what the name is, and age, check-in name. So now if we come right here and say p1.party, it's going to give us this output. It's party time, check-in name Abdul, age is 12. Now let's inherit this person class to a student class. So a student is a person, and let's define its init done the method, and in the init done the method, of course, I want the name, the age of the student, and then the level of the student. Now the question now is, how do I put in the name and the age that is already inserted in the init method of the person class that we have? So in this instance, what we do is now we call the instance method. We don't have to do self.name again. That would be wrong because already there is a self.name that exists here. So we're going to call the super method that is called the init of person. So it will be init that is called the init of the person class, and then put in the expected values, and then the last one is the level, which doesn't exist in person, and then put in the level. So right here we're calling super so that we can enter the name and age, because that super has been inherited by the student class. And because it's been inherited by the student class, it also has taken the party method. So let's instantiate S1, the student S1. And I'm going to call the student Malik 23. So let's say S1 dot party. Oh, I forgot to put the level for the student here. So you can see I have the level here. So S1 dot party, let me comment out the P1. S1 dot party shows it is party time, check-in name Malik, and age 23. It's no longer using the Abdul name because we are calling S1 a student, and the student is called Malik. It uses Malik here. When we call the party method, it calls the method in the person's class, but it uses the Malik and the age that is entered in the student class. Let's also add an override of this party method here. If I override the party method, all I'll see is the party method on the student. It's just going to show me venue area because it has overridden. It's not going to run this anymore. It's going to run this. And if I want it to run the first one, what I'll do, you can guess, is to say super party. So super party will make it run the method from the parent class, which is the party method. So you can see here it's saying it's party time, check-in name Malik, and age 23, and then it shows the venue. We can also do a little bit more. When we check the age and code, we want to see if that student should be allowed in. If you're greater than 17, that's when you get access. So I will say if self.age is greater than 17, then it should print you can go in, else print you are too young at age for this party. So I'll put here self.age. So right now, what it does is that it checks if you are greater than 17, you can go in. If you're not, it's going to say you're too young. So let's give it a try. So let's change this to say 14. You see, it says you are too young at 14 for this party. So it's not going to let you in at that. But then it still shows you the code. It still runs this. It shows you the code. So what do we do? What we can do is to return. If you can go in, then return true. If you cannot go in, then return false. So right here, what we'll do, we'll say if super, that is if true, basically this returns true or false. So if true, and how does it know it's true? It checks the age here. If it is true, if you can go in, it gives us true. If you can't go in, it signs and says false. Can't go in. So I'll check here if true, and if it is true, it gives the code. If it is not true, that is you can't go in, then it's not going to give the code. You can see right here, it's saying it's party time. Checking name Malik and age 14. He said you are too young at 14 for this party. But if we change the age to be beyond 18, you see it's going to say, yeah, you can go in, and then it gives us that code. Now that's how flexible it is. It's calling at this point is using super to determine if we can run the other codes that is in the student party method.